Yeah, g'day YouTubers. Tinker O'Toole again with another video. Today I'm going to talk about turning things on a lathe, the accuracy that you require, the accuracy that you get. So if you require very fine accuracy of say around a half a thou, so we're starting to talk microns, you can actually get it on a lathe like this on the Hercus. I've actually made this dead center because someone decided that they would bore this out a little bit bigger, and they bored it straight. So I had to bore it with a taper, and I had to make my own Morse taper. And you can put the Morse taper in and out, and you can get different run out. So even though they're a dead center, dead centers can have run out. And if you zoom in and you look at the dial gauge, one graduation is 0.01 of a millimeter, but if we rotate this around, which I'm rotating at the moment, you can barely see that needle move. So as I rotate, you can see I'm rotating around now, and you can't see the needle move. Yet if you turn the motor on, you'll get fluctuations, whether it's harmonics or whatever. It'll start to bounce. Sometimes it does, sometimes it doesn't. It depends on the speed that you go and everything else. But if I were to turn the lathe on, you'll get that. That's just quite normal. It's not a practice that I sort of would encourage to turn your lathe on while that's going, because it's going to put abnormal wear on the base of the tip, unless it's some of the tips have got actually synthetic what are they? The red stone, rubies, synthetic stone on there, polished. So, yeah, look, just bear in mind, you're better off rotating that by hand like that and checking your dial gauge, and you zoom in, you just have a look. I can't see that move with my eyes. So, yeah, if that's 0.01 between each graduation and I'm rotating, that's going to be 0.001 or something like that. It's in microns. So you can get that accuracy on a lathe like this, but also remember that I've done the bearings, the adjustment. You've got the shim in there, and the manufacturer recommends between 1 and 2 thou. So I opted for 1 thou rather than 2 thou. I wanted better accuracy, so I adjusted this to 1 thou. Now, the other thing that's interesting, at what temperature do you adjust it? Well, the best thing that I found out is turn this lathe on and run it for about 10 minutes. Bring it up to operating temperature, and you'll find out that the bearings will rise in temperature, and you will get a different reading between cold and normal running temperature. So it's best done after about 10 minutes of running. I know one particular person that has a gun lathe, and when he's doing the bore and everything else, he'll run that for 10 minutes before he does anything. So yeah, that's a great idea to do that before you make that adjustment. The next thing that you can find out in your lathe is the ways can be worn, right? So there's so many other parts. The ways can be worn, the cross feed, the compound slide, the list just goes on and on all the gibs. The adjustment bolts on the gibs may not be adjusted properly. The list goes on and on. The tailstock slide could be worn. It goes on and on and on. And then the next thing is, so if you're to do all that maintenance and you know where your lathe is out or by how much it's out, can give you an advantage. Now, the next thing that sometimes that you can't control, when we're talking about speeds and feeds, and we're talking about surface finishes, the worst metal that I find that you can turn is just plain old mild steel, or 1020 bright steel, same bloody thing, mild steel, is that it doesn't leave a good surface finish. Now, if it doesn't leave a good surface finish, then if you put the micrometer on it, it's going to be all over the place. Now, yes, you can get some fine emery paper and some oil, and you can run that over and you can smooth that out a little bit. But nonetheless, yeah, look, mild steel, I just don't want to touch it. I'd rather use some high quality metal that's got a little bit of lead in it. A lot of the high quality metals that we use for turning in a lathe have a little bit of lead in there, which actually helps to give a smooth finish. I think 4140 is a good choice. It's got a little bit of lead in it and it gives a reasonably good finish. Now, when we're talking speeds and feeds and you're not used to a lathe, I generally only run around between 500 and 600 RPM, and I slow my feed down because I've got plenty of time. So I generally have a fairly low speed and a low feed rate as well. And I generally get a pretty bloody good finish doing it that way. You could do it the opposite. You can go high speed and you can play around, but I think playing around is probably better than looking up a chart, because there are charts out there for all different metals, speeds and feed charts, but nothing beats experience. So once you've got a bit of experience under your belt and you've played around for hours on end, turning and changing speeds and feed rates, you get to know after a while what metal you're using as to what speed and feed that you should use. Now, one thing that's absolutely a luxury to turn is when you're talking brass. So there's a piece of brass there and you get a beautiful finish on it, a nice smooth finish. Now, you can get better than what I've got here. You can see the little lines still, right? You can get better than that, but that's good enough for me. And aluminium's another one, turns really good. So yeah, mild steel. So don't expect to run a micrometer or a dial gauge over mild steel and say, oh, why is it bouncing? Why is it all over the place? One of the reasons, or not one of the reasons, the main reason is the surface finish. Whether you use high-speed steel or carbide bits, it tears into mild steel. Mild steel does not give a beautiful smooth finish. It rips into it. That's why it leaves a terrible finish. It just doesn't cut properly. It's terrible metal to turn. So yeah, but there's nothing wrong with using mild steel. Let's just say you wanted to make a couple of gate hinges. So it's just a matter of having a pin fitting in the tube. And mild steel's fine. You know, what you're going to do is weld the pin in there, and it doesn't matter about the surface finish. But if you're talking about something precision, then don't rely on mild steel to do the trick for you. Go for 4140 or something like that. There, 4140 is a good all-rounder. It's weldable. You can harden it. Mild steel, you can't really harden it that much. There's not much you can do with the hardness of it, but certainly 4140 and some of the other grades out there, you can flame harden and quench them quite easily. So they're brilliant metals to work with, and they give a beautiful surface finish. So just to briefly recap, spend a bit of time setting your lathe up, doing the maintenance, checking the gibs, adjusting all that sort of thing, and tailstock alignment, make sure you do that. If you don't have a test bar, I've got a test bar, so it's pretty easy for me. It's got centers at each end, plus it's Morse taper too, so I can put it in the tailstock and do an alignment with tailstock alignment. It's really good for that. Now, if you don't have, let's say you don't have a test bar, because test bars can be quite expensive, you should have a Morse taper in your tailstock, and hopefully you've got a Morse taper in your headstock. If you haven't, they're not that expensive to buy one. Usually this is Morse taper 3, but as I said, I had to make my own up. And if you bring the 2 points together, and they're beautiful sharp points, you can actually align it just by eye, and you might be a couple of thou out at worst. So that's the poor man's way of doing it. The professional way of doing it is using a test bar, but as I said, test bars can cost hundreds of dollars, and a lot of people don't want to spend that. So yeah, look, thanks for watching. Bye for now.